In today's video lesson, we're going to learn about different types of chemical reactions. So we'll be reviewing the material that we would have learned in grade 10, but then expanding a little bit on that material, especially when it comes to single displacement reactions. And we'll learn how to predict whether a reaction will happen or not. In a synthesis reaction, an element or a small compound will combine with one or more elements in compounds to form a new substance. So the general formula is A plus B makes AB. If we look at the example we have here, we have hydrogen reacting with oxygen to make water. We can see that the reaction isn't balanced, so we would put a 2 here to give us 2 oxygens on the product side. But now we have 4 hydrogens, so we need to put a 2 here. So that is the balanced chemical equation. Now in a decomposition reaction, a compound breaks down into elements or smaller compounds. And I always remember this one because when an animal decomposes in nature, it's breaking down into its smaller components. So that helps me remember. The synthesis reaction, I remember that one because of when you're synthesizing, you're building up, you're putting together. So in this example, the general formula is AB breaks apart into A plus B. And this is the reverse reaction, so water can also decompose into its individual elemental parts. So we need a 2 here and a 2 here, and then our reaction is balanced. Now, a combustion reaction is a reaction of an element or a compound with oxygen, and we form oxides as products of these reactions. So if we look, so one example would be sulfur and oxygen makes sulfur dioxide, or in the example we have down here, calcium plus oxygen makes calcium oxide. We can see that we don't have quite enough oxygens on the product side, so now we'll need to put a 2 here, so our reaction is balanced. Now, if we don't have enough oxygen, in a combustion reaction with carbon, hydrogen, and oxygen, so hydrocarbons or anything that has CHO, you can have some dangerous byproducts. So when you burn anything or combust anything with carbon, hydrogen, and oxygen, it will make carbon dioxide and water for products if there's sufficient oxygen available. But if there's not, that's called incomplete combustion. So the first is called complete combustion. You'll end up in incomplete combustion producing carbon monoxide, which is a poisonous, odorless gas, and some carbon as well, which we call soot. In a single displacement reaction, one element within a compound is being replaced by another element. So we have sodium and copper 1 bromide producing copper and sodium bromide. This reaction is balanced. So our general formula is A plus BC makes B plus AC. So what's happening is this is jumping and replacing the other ion to make that. Same thing. So sodium is jumping and knocking out copper and forming sodium bromide. But not all reactions will occur. Not all metals are going to be able to displace the metal that's in the compound during the reaction. So to be able to do it, the metal must be more reactive than the metal in the compound. So you have to look at the metal activity series. So this series is showing us anything near the top is more reactive than the ones down here. So it kind of makes sense. These metals down here, silver, gold, platinum, we use them in jewelry. The reason why we use them in jewelry is that they don't react. They're non-reactive metals, and silver tarnishes, so it does react some, but gold and platinum do not. So they're the least reactive. Potassium, sodium, calcium, magnesium, etc., they're more reactive because they do react with water, air. And it also makes sense when you look on the periodic table where they're found. These are found on the left side of the periodic table. So remember, reactivity of metals increases as you move to the left. These ones are found on the right. And then also, even within a group, so potassium and sodium, potassium is lower than sodium, so it's more reactive. So that helps you understand as well. So as I said before, if the metal is higher up on the series than the metal in the compound, a reaction will happen. If it isn't, then no reaction will happen, and you'll just write NR. So if you were to do an example with this, iron plus sodium iodide, iron is lower on the metal activity series than sodium, so there's not going to be a reaction. So we're just going to write NR for no reaction. The next example, we have sodium trying to react with magnesium oxide. Now sodium is an alkali metal, magnesium isn't, so sodium is going to displace magnesium. So remember, we have to use our crossover rule to figure out our product. So sodium has a charge of +1, oxygen has a charge of -2, so we're going to cross those over. You're going to get Na2O. So we will write that Na2O plus magnesium, and now we need to balance it, so we need to put a 2 here, and that's all. Our next reaction, we're trying to react with silver with lead 2 nitrate. If we look on the periodic table or on the metal activity series, silver is lower down than lead, so there's not going to be a reaction. So no reaction. Our next reaction is with sodium again and calcium oxide. So this one will form a reaction because sodium's an alkali metal. So again, calcium has a charge of +2 just like magnesium, so it's going to be Na2O plus calcium. So again, to balance it, we'll need to put a 2 there. Our last type of reaction is a double displacement reaction, and in that case, cations are traded between 2 ionic compounds, so AB plus CD makes CB plus AD. So literally what's happening is this is swapping and this is swapping. And then here's an example. So there's a variety of different types of double displacement reactions. This one's an acid-base reaction. We'll spend more time looking at those a little bit later. So hydrochloric acid plus sodium hydroxide produces water and sodium chloride. So you'll learn in a double displacement reaction involving acids and bases, they're called neutralization reactions. When you react an acid with a base, you form water and a salt as the byproducts. Other types of double displacement reactions may form a precipitate, so those ones might be called precipitate reactions. And again, just like with the metal activity series, not all solutions mixed together will form precipitates. So in those cases, or will neutralize things. So sometimes you'll mix 2 solutions together and no reaction will occur. So that can happen as well, but we'll spend time exploring that a little bit later.